thank you everyone for coming. This is the second in a series of talks in our data science and AI initiative. Dr. Angel Pineda from Math will talk about data wrangling and visualization. And I want to say that part of this effort, the goal of this effort is to get everybody to sign up to the Star HPC GPU cluster that Professor Curry is running. And we have temporary username and passwords here, which I will hand out to you. And if you have a laptop, feel free to log on and follow along. Okay, I think that's enough said. Please take it away.
Thank you, Paul, for the introduction. I want to thank everybody for showing up. This is like a fantastic audience to have. I'm going to talk a little bit about data wrangling and visualization using the Star cluster. And in particular, is going to be related to a data set that comes from a local healthcare provider, Harmony Healthcare. So I'll give a little bit of the context of where the data came from and some of the ideas of data cleaning and visualization.
Could you full screen, Control L?
Acknowledgement. So, I want to thank support from NIH and from 2 NSF grants, one from Dr. Curry and one from Paul and Michael, who gives support for the cluster. So in order for me to be able, and if you see those temporary password accounts that you all have accessible, it was Michael who sort of created the accounts and links them to the place where I can put stuff and it automatically goes to all of you. So whenever, this is a plug for getting support, for getting things to run on the cluster, Michael is very good at helping us get things done. So I want to start with more than funding acknowledgement, the background for this project or this data set is a external consulting project from 2 classes. One of them is the Probability Statistics 2 class in spring 2025. That was this group of students here on the left. It's the first time that we reached out to Dr. Laurie Ward at Harmony Healthcare and said, we have statistics students, they want to do a project, can we work together on something that is of interest to you? And in particular, she's got data from like thousands of patients and whether or not they use the emergency room. Oh, I shouldn't move.
No, you're fine.
And for Harmony Healthcare, is way better if a patient goes and gets primary care, then shows up in the emergency room with a serious condition. So what they want to do is identify patients before they go to the emergency room and give them extra support so they can get regular preventative care. So Dr. Ward is interested in that, and she's got lots of data, and I've got students who want to work with real data. So the data cleaning component of this, it really comes from having messy data that was inputted by hand into spreadsheets that then gets uploaded into what we have. So the first time that we worked with that data was the spring of 2025 in a mathematical statistics class. The second time that we worked with data was this last fall in the Foundations of Data Science class. And both the previous talk about how to do handwritten digit recognition and some of this data cleaning comes from these classes. So this is the Foundations of Data Science class. It's the first class in a new data science and machine learning major that teaches students how to work with data. And it might be like, cleaning data, visualizing data, running models on the data. Right now we're covering databases in SQL. It's just like a little sprinkling of all of the content that students are going to see in future parts of that curriculum. I also want to thank Kate, who's sitting in the audience. He did an honors section in our probability statistics class on this data set as well. And some of the ideas and some of the results I'm going to show just come from the students doing their work. So why am I here? I guess this is like now my always slide for any of the DSAI events. And it's, I am here because of people at Hofstra who wrote a grant for a cluster hire. And the 4 people in the cluster hire are in this photo. So, as Paul commented earlier, this is part of a series of talks. His vibe coding talk was really cool. I actually want to learn more about vibe coding now. Today I'm talking about data wrangling and visualization. And then Gustavo is going to talk about version control on GitHub. And that's something that my lab does. So the students that work in my research, we all use GitHub to sort of do version control, share data, and when we publish a paper, we put our code on GitHub. So that's a tool that is going to help my students come to Gustavo's talk to use it. And then Michael is going to talk about automation, I imagine shell scripting, but I'm going to hear more. I'm curious to learn more about how to do that as well. Okay, so this is a little bit of the background for where the data comes from. So it's a student consulting project, and I'm a big fan of projects instead of final exams for data-oriented classes. It gives the students a line on their resume. They have an academic projects line with an external client where they will say, we did this project and this is what were our results. And it's something that's helpful for them to talk in an interview. So the data is interesting because it's got hundreds of features, thousands of observations. There's inconsistent capitalization because it was generated by people putting it on a spreadsheet. There's missing values. It's messy, right? And it's messy in a way that it's beyond what you see on a Kaggle data set. I don't know if you're familiar with that repository of data. That's like semi-messy usually. It's usually been pretty cleaned up. And the machine learning data sets are pretty clean to begin with. So I just want to talk a little bit about what it takes before you can run your machine learning model. So the goal of what I'm going to talk today is much more about how to clean and explore the data a little bit before we build the models. So I'm not going to talk about the models themselves, the thing that the students were doing in their project, right? So their goal was to be able to predict who was going to use the emergency room or not, based on this data. So I'm going to skip all of the model building part, and I'm going to go straight to the results of the two classes. So in Math 138 in the spring of 2025, Lasso is a technique that basically does logistic regression, like a linear model with a kind of regularization that promotes sparsity. What that means is that it does feature selection. It both selects which variables you're going to use to predict and does the prediction at the same time. And there's a lot of numbers here. We're not going to talk about the details of cross-validation, but I just want to have you look at this number, 0.696. So that is essentially our summary of our best guess of the number of times that we would correctly predict which person was going to use an emergency room, from other data not related to the emergency room. So 70% better than chance, but it's, there's room to improve. By the way, if anybody have any questions anywhere along the way, please just raise your hand and stop me. This is very casual. So that was the very first time that we were looking at the data. It was a mathematical statistics class. So in that class, we prove things. So it's not like a data class. It's much more of prove the central limit theorem. And by the way, I'm going to do some things in R. But then in the data science class, the first class in the data science program, they work with data in every project. They don't have as much theory in that class, but there's a lot of programming and data in that class. So there was a pair of students who chose this same problem. And what we did is we tried a different approach. So instead of doing the lasso technique that does that, which variables am I going to use for this classification, and doing the classification at the same time, it does it in two kind of different steps. So there's an algorithm for finding which features you're going to use to predict something that's called the greedy algorithm. And that basically says, look, I've got 700 features in this data set. I'm going to try every single one of them. And then the one that helps me figure out if somebody's going to use the emergency room or not, I'm going to use that one. So out of the 700, you pick the one. Then you remove it. And then what you do is you add all the other 699 features to that one. And now, the second one added to the first one that best classifies which person is going to use the emergency room or not, then that becomes your two-feature model, right? And you basically keep adding features in this way until you stop improving. So it's greedy. It's not optimal. It's not optimal because it might be that there's a different combination that does it better, but it's a relatively fast way of picking your features. And then we just did regular logistic regression after doing our feature selection that way. The number that I want you to see is this cross-validated AUC for the greedy forward selection. So we ended up getting a 0.79. So, I mean, it's 0.69, 0.79. It's better. Still not something that I would go to Dr. Ward and go, you know what, you should use this to predict. But, you know, we have another group of students who might look at it this semester. And the goal is that through iteration, eventually we would be able to squeeze everything out. So that was the punchline. But yes?
What number are you looking for to be confident on?
I don't have a, Gustavo, that's something to ask Dr. Ward. Because she might say 80% might be good enough for her. For me, I saw a huge improvement from 70 to 80. So I'm going like, I need to go until I stop improving and then ask her, is this something that is useful for you? There are companies that are selling this kind of software to healthcare providers. So in a dream world, we would get to a point where we would be competitive, and then maybe we could start our own, startup. So, yeah.
Why wouldn't 80% be useful?
Yeah, so
versus no knowledge.
Yeah, so that's a great question, Eddie. My knee-jerk reaction is I don't know the cost of the intervention. So if you, they got thousands, like I don't know how many, maybe 100,000 patients. I don't know. So if you, so I would need to look at the number of people that are like the threshold that you select, and if the intervention is cheap, then 80% would be probably useful. But if the intervention is expensive, then you would be spending a fair amount of resources on people who might not use it. But honestly, the interventions that I think that they're thinking about is sending somebody to your house and sort of say, there's this like closer clinic that could serve you in preventative care. And I think that's a resource intensive.
The other question is, can you give us an example of?
We are going to do this is we're going to use the cluster to look at the data set. So if you have everything, I'm going to be projecting everything that I'm doing. But if you want to actually just use the cluster to play with this data set, what I would like you to do is to go to this address, HTTPS on demand. Oh, I don't know what the other O is. Open
on demand.
Open on demand, star.hofstra.edu. And there are these temporary logins that are on, and if you don't have one, we have extra ones. And then you can log in with that account and then navigate. Okay, so first you need to log in. Maybe I'm going to start doing that. But if you've done so basically I'm gonna tell you what we're gonna do, and then we're gonna do it. So we're gonna log in. You're gonna use your login. You have to be really careful at putting in your login and password. And then you're gonna start a Jupyter Lab session. And then you're gonna basically ask for allocation of resources in the cluster. And the queue is gonna be normal. As opposed to handwritten recognition, we don't need a GPU for this, so you would just use a CPU. We would just need one core, actually one GPU, that's all. It's 0 GPUs in this. And then it would be 1 hour, which is more than what we need. And then you'll have to wait a little bit until there is a little button that says that you can connect to the notebook. From there, you're gonna be able to see on your left-hand side some folders available, and the code and data for this particular Lunch and Learn is going to be on the 2026 folder, data wrangling and visualization. And then in that folder, you're going to see Harmony Healthcare data, wrangling, and data visualization. So I'm gonna leave the PDF.
Yeah, maybe it's better to share the screen. Yeah.
Right, exactly. So what I did, right, is I went OOD. And then you will see the screen. And in the screen, actually, maybe I'll do it as a. Surely you're not using. Oh, I think there's an extra one. Perfect. Oh, I guess I could have just used. Yeah, I'll use this. I'll use this one. So I'll just do it as a user. So for example, if you heard earlier, Eddie was saying how if you want to use the cluster, you can use it. You don't need to require like a large GPU to use it. But when you have an account in the cluster, you would log in using the computer science account. Right now, we're getting. And then we get to this screen. By the way, if anybody is wanting to follow along and is get stuck in any way, just raise your hand and we can help you. All right, looks like we're on the same page. So here, and then I will go to Jupyter Lab. And in Jupyter Lab, so here I'm going to ask for resources. And Michael, please feel free to correct me anything because so it's going to be lunch and learn. The partition is the same. The QoS is normal. I don't need a GPU for this application because it's not so computationally intensive. And now I'm just going to use a CPU. I don't need a GPU.
It doesn't matter if you choose CPU, it doesn't matter.
It doesn't matter. Great. And then I'm just going to launch. Right. And now here we wait patiently because it takes a little while before. But, I just want to sort of show you how easy it is to log on to the cluster. And the resources available, we're not even going to get close to using them. Like we've had other talks in terms of what is available on the cluster, and it's more than what I would possibly need right now in my research. So now we are here. And if you, depending on who used your account last time, you might be in a different place in terms of this directory. So in case you don't see this 2026, you might need to click on that in order to get to the 2026 folder, right? But then we're going to get the 2026 folder. And here are the different lunch and learn. So we're going to do data wrangling and visualization. And now in data wrangling and visualization, there is 1 week of the data set itself. And then there is a Jupyter Notebook. The Jupyter Notebook is here. So I'm just going to click on the Jupyter Notebook. And that will bring up not the version of the Jupyter Notebook that I thought I had. So I thought I had so we're going to have to do some like real-time changes on the Jupyter Notebook itself. I'll explain to you a little bit later why is it that actually, as a second part of this talk, I'll do a little bit of coding using command completion on Google Colab, which is not vibe coding, which is like it all does it for you, but more like you put a comment and then it suggests code for you. So it's for people who are not ready to let the computer do the whole thing for them, and they just need like a little push, like me. So anyway, so so now I'm not sure which version I ended up putting here, but I thought it was this. So okay, so what we're gonna do, because it's not gonna find it in this Google Drive, I'm going to delete this cell. And if you are running this with me, what I want you to do is instead of, so right now it's looking for this Harmony Healthcare 1 week file in my Google Drive. But right now, that's not where it is. So it's just in the same folder. So all we're gonna do is delete everything except for the name of the file. I'll give you a moment because now it's gonna look for the file in the same folder where the Jupyter Notebook is. And by the way, in case you're not used to this, it always gives me a warning of some sort. Like whenever I'm working with, Python and Linux, some versions of the software were created with one version, but then I'm running a different version. So I don't worry about it. Right, so now I just ran the first cell. I'm going to run the second cell now. Right, and the second cell is the data itself. So it gives me a version. So now Eddie was asking for some of the variables, right? So you can see age, electronic health record sex, emergency department episode date, claim, urine creatine result, there's cholesterol results. And then, so there are, and if you look here, there are 708 different variables, most of them empty, that are collected from individuals who come into this clinic, right? So we could more properly explore all of them, but this is the kind that what the data set looks like. And that goal is to like the eventual goal that the students were doing was identify maybe 10 of those variables that would be most predictive of the whether somebody was going to use the emergency room or not. So we have that data set originally, and now what I'm going to do is something that instead of like the real problem, I'm going to do something that is just illustrative of the kind of steps that we would use. So in order to sort of keep track of things a little simply, the first thing that I might do is I'm going to create a small version of this data set that only has 10 rows and 10 columns. Right. So, and if we look at that, now we have a small data set that has 10 rows and 10 columns. Let's just look at some of the things that we might need to clean from this data set. So I love to hear the comments from the back. They might be helpful for all of us. Do you guys want to share something?
No, not really.
Okay.
I'm just puzzled.
There's lots of things that puzzle me all the time, so we could puzzle together. So one thing, I actually did exactly 10 because I wanted to highlight this value. Because if you look at the sex, there's all lowercase except for that value. If you were to do a classification that would group electronic health record sex into categories, and if it was not case sensitive, then it would consider that like a third category. So one of the data cleaning steps that you might need to do when the data comes out from the wild is to make sure that it has consistent capitalization. That's, yes.
No, finish your thought.
No, that's it.
I saw this as an Excel file. Is there a benefit, or is there? I would imagine this would be a CSV file instead. Is there?
Yeah, so it's the file in the format that the doctor gave it to us. But when I say, when the cleaned data set, I save it as a CSV file. That's, and this is where I get a little bit outside of my depth, because the CSV file, I think it's like smaller, but for the sizes that I'm looking at, they're almost interchangeable to me. I think that you know more.
I was just going to say, it's being transformed into a data frame that can be basically used almost as an equivalent of a CSV file.
There's not like any like metadata or anything that comes from the Excel.
No. Basically the function read Excel like automatically transforms it and accounts for any sort of discrepancies.
Thank you.
Yeah. So and please, I'm giving the talk, but I am sure that we can learn a lot from each other. So please help me with this. So one of the things that I worry about is, and this is not something I worry about in my research in MRI, like the data that comes from an MRI scanner is machine generated. It's not human typed in. So capitalization is not like a general concern, but if you're doing this kind of consulting project, then you worry about that. The other thing that you might worry about is format of dates. So the dates here you need to check things. Is this considering that date as a character string, or is it a date? So some of the things that you might need to do is to change the format of that particular column to be specifically a date so that you can treat it as such. And the other thing to note is a lot of this data has missing values, right? So a very large percentage of this is missing. So there are different methods for dealing with missing variables. Data imputation is one, where you replace the missing values with something. You can also remove rows and columns if there's a certain percentage of the data that is missing, right? So those are the kinds of things that we might consider when we're thinking about doing data cleaning. Yes?
Would it be useful to calculate the length of the stay of the person using the admit location and discharge?
Yeah, so now what you're getting at is very interesting. They're engineered variables. So I'm gonna have a very simple example of an engineered variable. I think the students tried different ones, but what you're getting to is something that is very useful when you're doing something like this. It's like they might not have looked at. Now, the engineered variable makes it explicit. The kind of classification models might do it explicitly, because in the way that they combine those two variables, they might be looking at the difference between those two. But you can also make it explicit by creating another column, which is length of stay, which would take the difference between the two. Yeah, great question. And suggestions, this is work in progress. So if you have suggestions, I'll take them as well. Right, so this is the kind of data that we're looking at, and I'm gonna do just some very simple things. The first thing that I just wanna look at the variables in the data set. Right, so at least in this simple one, so, and by, it makes it a little simpler for me. I'm just gonna print the columns, and you can see that at least in the first 10, there's age, electronic health record, sex, and then a lot of variables that have to do with the emergency department admittance, I didn't even get to their cholesterol and things like that. So one of the things that we might do is remove the columns that are completely empty, right? So I'm gonna show you a little bit towards the end, different ways of generating this line of code, because there's not one single way of doing it. But for example, here I'm creating a clean version of the data set, so not just small but clean. And here I'm going to use the drop NA. So the NA is not a number. So, and it's saying which one I'm going to drop. I'm going to drop columns, and you can have different conditions. Like I might drop when 70% of the values are NAs or 90% of the values are NAs. I talked to Dr. Warren. She goes like, basically only drop things if there's nothing in there. So she wanted to be super conservative. So she goes, so then I only drop the ones that are completely empty. And I create another version of my data frame. Right, so now there is this other version of my data frame, and I drop the ones that were completely empty. I'm starting to have a little bit of a hard time of keeping track of the size of things. So, so the shape of this small data frame of the original small one is 1010. The shape of the clean data set is 10.8. So basically, this is a simple way of just for me to check that there were only two columns that were completely empty, and I just removed, right? So now I have another small and clean data frame that I removed all the columns that were missing. Now, I'm going to do the same kind of thing now with the, so there's this command that, there's a lot of commands in here, but the one that is, I guess, most relevant is str lower. So this is a command that takes text and makes it all lowercase. And, when you have things like, and, there's other ways that you can compare things that are misspelled. There's a whole other level of detailed analysis that you can do. I'm just doing very simple stuff, like just make the EHR text and apply the string lower command, which makes sure that it's all lowercase. And here, the one value that I want you to pay attention is the very last one, right? So that's the one that used to be a capital F, and now it's a lowercase f. So now at least I have a category that I might use in some, classification method now has two categories, male and female, not a potential third if it misclassified the capital letter. So what, right.
Question.
Yeah.
I see that you did string that lower, but there would be a way to prevent duplicates as well if you take into consideration of removing such white space, because you don't want, for example, you have male by chance.
You mean if somebody left a space before or after? Now you're getting to the things that the students do better than me. Right, you know, because they've looked, so they've looked at the data set a lot more carefully.
Okay.
And when you do, like, for example, I think that what you're saying is, we can see if we can find a distinct number of categories and see if it gives us just 2.
Right.
It might give us 5 because one had space before, one space after, or maybe there was a misspelling.
Exactly.
So that's a great commentary. Like a practical data cleaning version of this would be when you have a reduced number of variables, is to ask it for how many distinct categories are there of this variable, and if there's only 2, then we're good. But if there's 5, then we know we need to do more tweaking to get it right. That's a great suggestion. And interestingly, I should know better because we covered that, I think, last week in the Foundations of Data Science, but in the context of SQL, a different language that works more with data frame, with looking at data structure. Yeah.
A lot of values. How are you going to treat them?
Yeah. So in practice, my ideal method would be a method that handles missing data well, like decision trees. There are methods of classification that can handle missing data well. So that would be something that I would do. I think in practice, what we might do, like the simplest thing that we did is replace by the median or like the mode. So, an interesting question, and I'll come back in a second. I've done mice, which is like a model-based imputation method to see if it did better. And in my experience, in the very limited problems that I've done in this way, I've tried it 3 different ways with the models that I had, and there wasn't like a huge difference in the general output. Yeah.
If you ask me, I feel like we should create like a little Python code to see what's the percentage of NAN values inside of each column. Because I feel like in this case, we would need to remove ED episode DC disk mode in this case.
Yeah, that's a great suggestion. The students did that. They had different thresholds of what percentage of the columns were empty, and they looked at the results depending on changing that percentage. There wasn't a big difference. And when we asked Dr. Ward, she was very wary of removal of columns based on a percentage of the entries being empty. Yeah.
And according to
Warren?
Dr. Warren.
Oh.
So what are the cases for like columns that we don't remove columns that have a lot of NAN values?
Then they imagine that you don't remove them. All that we're doing is the first thing that we do is feature selection. So if they don't result in like meaningful value added in making that classification, they just get removed. So in the original, maybe I'll show you a little bit more of the other results, but we ended up with 10 variables. So, and if you had most of your data missing, those columns didn't end up being picked as by the greedy method or by lasso for being the meaningful ones. So there's a little bit like self-selection in that method. Yeah.
Speaking off that, like, what are some standards that you would use to determine like which are significant, which features are significant or not?
Yeah. So honestly, I'm kind of a fan of the greedy method. Mm-hmm. What is the task that you're doing? Your task is to classify whether somebody is going to go to the emergency room or not. Okay. So whatever feature has the most impact on that task performance, then I keep it. There are other ways, like Lasso actually has a slightly different criteria. But for me, it would be, that's why I like the greedy kind of method, because it's very tied to if you're doing a different task, it would pick a different set of features for it.
Okay,
like
you would get like kind of close to where you're looking for.
Well, I think, yeah, how close to optimal is greedy, that I cannot answer. Okay. I don't know. I don't know exactly. I don't have a good sense for how close it gets to the optimum. Yeah.
We could try comparing subsets of data where you had a smaller sample size, like admit location, to determine if South Nassau Community Hospital might have statistically significant differences from Nassau University. 100%.
Yeah, so that's a great question. So that's how you find the optimal. is using, there are methods that would explore every subset, and that's a combinatorially hard problem. It just takes very long. So so the way that you could do it would be, in a sense, like reduce your 700 to a size that is you can approach using best subset methods, which I think that's how you get the best, if you can afford the time. Yeah.
You have, I just want to ask a question.
Yeah.
It's related to security of it, aspect of it, but you have all this data, age, sex, and admit. What steps are being taken to anonymize that person's identity,
Yeah, that is a great question. And that's where I trust my client, Dr. Ward, because I said, whatever you give me is going to be completely non-identified data. Now, there's always sophisticated ways to try to extract the identity from this data set. But the data set, as it was given to me, had met the standards of Harmony Healthcare for being de-identified. So could a neural network coupled with some other data set maybe try to find who these people are? Maybe, but I think it passed the standards that my client gave us. Yeah. Thank you.
Could you just follow up on this? What is the smaller group for you? Or the smaller groups of four?
Yeah. So the way that I'm doing it, I'm just adding one at a time.
All right.
But it might be that the order in which I'm adding them doesn't give me the best subset, the best subgroup. It might be a combination that wasn't the first 10 plus the other one. It could be that if I had done them in a different order, I would get a better performance. So the best 10 might not be the ones that arise by taking the one that does best, followed by the second, followed by the third. It might be a different set. And the only way you can find out which is the best is by trying every subset. Yeah.
And the small group allows you to do that.
That small group makes it so that I don't wait until the end of the universe to do that. Yeah.
Let's just say you identify some interesting trends within a subset of data. Do you have ways to extrapolate or correlate without having the location on hand for the larger, like, can you make some assumptions that could be generalizable without helpful information like that?
So I don't know if I understand your question. I'll tell you that the way that we assess this is with a training set and a testing set. So we have your data is like a 1 week data. We have like a month worth of data. So we only take the first 1 week to do all of this. But our goal is to predict the performance on data that we haven't seen. So that's, I don't know if that's the generalization that you were saying.
I guess the idea would be you have a small subset that includes location data, and you're trying to figure out, would that be generalizable to the larger population, and maybe even apply to these other data points where you don't have location, but you would assume that they would correlate well with one of your two respective locations.
Yeah, so I have a very small of information in that direction. When we did this originally, I'm going to give credit to the students. They did a literature search, and they found a similar study in Ireland. I mean, that's a very different location. And the features that we found were not dissimilar than the features that they found in that other group. But I'm going to say that it's probably very out of distribution data. Like, for example, the population in Long Island, who's going to use the emergency department, might be very different than Polynesia. It just turned out that with that Ireland data set, that the features that we found were, when we showed them to Dr. Ward, who is actually the person who knows something about this, she goes like, oh, those are reasonably consistent. But I don't know really, like, for example, if we were to look at a different location, my guess is that we would need to train for each subpopulation to really get a good results. Yeah.
Can you just comment on what the the clock time is for these calculations? You talked about the greedy versus the other one, and you said.
Correct. So
what are we talking? We're talking about hours, days, months?
For 1 week of this data set, we're talking about hours for greedy,
okay,
and minutes for lasso.
Okay.
So for a student project, that's reasonable.
Sure.
If you were doing this at scale, now I need to think about using the cluster in a smart way. I haven't thought about computational efficiency really, other than it takes me longer to do it, and other than doing every subset, which that we did try, and then, we just like got tired of waiting. Yeah.
So what's your philosophy on how you approach fitting the data? Because my limited understanding is if you overfit in a small population, you're gonna have very nice correlations, but it's gonna be less direct generalizable to larger populations. So like, how do you approach that with data like this?
Yeah, so that's a very fair question. Every result that I showed you earlier was a cross-validated result, which basically just means that I train on a subset and I test on another. And then I change the subset that I train on and I test on another. So every value is an average of predicting on another piece. Thanks for coming, Kate. So Kate is one of the students who did this work. So when I say the students figured that out, he was one. Yeah, so my approach when I have a limited amount of data is to do 5-fold, 10-fold cross-validation, and that's the number that I use when I say we're doing it a certain way. Great questions. Yeah.
One step further. So let's say St. Francis, supposed to be known for heart disease, treating heart disease. We're assuming that the patients who go there or end up there have some prior history with a cardiologist, and they've been under good care, and yet they still end up in the ER. Right. So does that become a cross in the cross here? What are we overlooking that even these people getting the best care end up in the ER for some heart disease issue?
Yeah, so I think that starts to get outside of my expertise. I think that's where having a partner like Dr. Ward, who worked, like she would be able to answer that question better. At this point, my experience is limited to like this data set and the statistical methods, but that's a great.
Still fits in the category that the small locational groups have merit.
Yeah, exactly. And also what you might probably want to do, honestly, is like once we can identify this, is there would be people who are likely to use the emergency room, and then you probably want to separate the ones who are already having proper preventive care, right? Because those are already having the intervention that you would give the others, and then you would try to reduce cost by giving preventative care to people who haven't.
I was just assuming that there would be some care, but yeah.
Which, for some, we have homeless people, we have a lot of people who don't have access to regular healthcare, whose first...
you never know who you're going to meet in the office.
Yeah, exactly. And here, for Harmony Healthcare, it is my understanding that that's one of their primary interesting demographics that they want to help, because both it helps them and it gives them, a decreased cost. Which is actually kind of an interesting thing, that this could be like an interdisciplinary project, right? Where there would be people who would look at it from the perspective of health inequality, and other people who are doing like, greedy algorithms for classification. So great question. So what I just showed was just a way of getting the capitalization concept. There was an earlier comment about a engineered variable. A very simple engineered variable is using whether somebody was admitted to the emergency room. If this was not empty, then the person used the emergency room. So, in the variable the data set doesn't have a variable that says this person came to the emergency room. So we engineer a variable a little bit like what's suggested in terms of the time of the stay. And then, so that is a variable that now just encodes that's our target variable. When we do our classification, that's the thing that we're going to try to predict with the other variables. So we construct it. And then we insert it into the data frame, right? So the data frame didn't have a person use the emergency room as one of its variables, but that's the target of our classification. So we insert into the data frame, and our new small, clean copy data set now has this ED visit variable, which is going to be the thing that we're going to be trying to predict. Now, if we were doing a prediction, we would want to remove all of the variables that are basically encoding the thing that we want to predict, right? So from the data set itself, anything that had ED in it, we would want to remove it and predict it from the others. So when we do that, then we're left with a very, very simple data set that, this is not the one that the students use, right? Because they had a lot more. But here we have our target variable, and you might say, oh, I'm going to use two variables, the age and the electronic health record sex of the person to predict whether they use the emergency room or not. So all of that was, just data cleaning that before you would get to a classification problem. A very, very simple visualization for something like this would be a side-by-side box plot. So a side-by-side box plot, would, would look like this. So the line here is the median. The whiskers are the so this is the first quartile, this is the third quartile, this is the maximum, and this is the minimum. There's no outliers in this box plot. So what you see is that it looks like the median age of people who didn't use the emergency room is a little bit higher, and there's a lot larger distribution. So it's not, nothing here is going to be like this one variable is going to tell you that somebody used the emergency room. It's going to be a lot of subtle changes that they combine to get that 70% or that 80%. So this is where I ran out of time to do this. I actually have loved the questions because it gave me a little bit more to talk about. I just want to show you something that Michael and I talked a little bit, but we didn't have time to implement it for this time. But the way that I was doing the coding here was just by knowing what I was going to write. What Paul showed you was a fully vibe coding, right? Where you just put in, some vibe. And I would say, I might say, clean this data set by removing missing values and making the variables have consistent capitalization, and then it would do its thing, and then I would iterate until I found it. What I want to show you here is Google Colab. So we have way more computing power in the Hofstra cluster than Google Colab gives us for free, but Google Colab also has GPUs, and it also has a Jupyter Notebook interface. And so this is the same code that you just saw me, or you maybe had been running on the cluster, but I'm running it on Google Colab. The one thing that I told Michael that we could consider adding is, so I had gotten up to this point. You see, it's the same point, but I couldn't remember how to do a side-by-side box plot in Python. So, most of you may have done this already or know how to do this already. Actually, certainly the students do. But I got to the point where I just made the comment, create side-by-side box plot. And then what happens next is that I think it uses Gemini because it's Google, but I'm not sure. In my other interfaces, I might use GitHub Copilot. But what it does, so this is a version of what the in-between version of what Paul did, then just coding yourself, and it's command completion. So after I write the comment of the thing that I want to do, Gemini, I imagine, suggests to me what the code should be. So when I wrote create a side-by-side box plot, it gave me the code to do the side-by-side box plot. So I don't even know what crosstab is. And I'm not even sure if this is going to work. But it gave me something. It's not done, right? So I guess so there's going to be more, right? So this command, Harmony Healthcare, I had to do the next letter so that it would, and then we're going to see. It did something that I'm going to have to check to see if it's really what I want. But I just wanted to end with a small example of like how I actually code. I used to, like Paul, I used to go to how do I do this? And
Stack Overflow, that's.
yeah. And then I would cut and paste, and then it would work or not. And I'm not quite at vibe coding yet, but I am at command completion to check and see how to get what I'm doing. So with that, I guess I just want to thank everybody for coming. And if anybody has any more questions or comments, I'd be happy to talk to you.